Welcome back, Generals, to another Let's Fix General 0 Hour to make the best game ever. Good, so what do we do with this session? Let's first check here in regards to things to merge. Let me see. Okay, we have a bunch of things here. Okay, so this one can be merged, I think. There. Library files to core, yeah, okay. Okay. Good. Next, how about we look at this guy here? Heap overflow. Fix buffer overrun and memory leaks in list box properties. Yeah. Let me get this branch. Cabal, okay. 009. Manage. Name, Cabal, URL, oof. Cabal. Will this work? Okay. Cabal, okay. And here's this here. Okay, let me open that branch here. Cabal. Listbox properties. Listbox properties. Okay, let me search for new. Okay, so new percentages. Okay, it's been cleaned up here and there. Otherwise, it's assigned here. Yeah. Okay, that's fair. That's it? Only this one allocation? Huh. Holds a percentage value. Token. Shouldn't this be 200? Should this be size 200? This adds unexpected arguments. Column width percentage. New percentages. Why is this 100? Prior sizes were 60 or 200. Did your testers change? Does it work? Let me remove my approval. Re-review. Okay, so progress starts at 0. Skill points change is this. Skill points change level up minus that. Skill points change level up minus level down. What does that mean? Level down. Level down. What is that? Skill points to go up, down a level. Skill points. What? To go up, down. Ah, okay. So it could go down. That's interesting. Get skill points level down. Skill points. Crash fix minor mod. Proof. Progress. Progress smaller equals 0. Oh, hold on. Progress 0, smaller equals 0. Can't be smaller than 0 here. Skill points. Probably not. I wonder if this condition actually can be removed. skill coins could be. I think this name is wrong for what it is. It should be skill points. Skill points. How do we call this? Skill points. It describes the amount of points we need to gather to reach the next level up, right? Let me just say skill points change is not a fitting name. Level up minus level down describes how many points are required to get to the next level. I think. And so I wonder if this condition is obsolete with this, because here you can say else return, right? Because then progress would be 0, and the progress can never be negative, right? Get skill files. Get skill points minus. I don't know. It could be. I wonder if there's actually already a function that describes this kind of thing. Maybe it is. Maybe not. Level gained. Skill points needed. Skill points needed. I guess that maybe a script could change the skill points to something that is lower than the level down. And then this would be negative, and then the progress could be smaller than 0, I guess. Maybe. Yeah. But other than this, it looks good to me, so I will approve this anyway. Yeah. Unify code of ASCII string. Updated with a more fleshed out endian handling compatibility header. Endian compat for the big file system. Okay, let's see. Oof. 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 That makes more sense. That makes more sense. Yeah. That makes a lot more sense. Yeah. PE. Big endian 64 to H. A to H. I would not. I think I would prefer. I think I would prefer this naming over the. I think I would prefer this naming with the bit size at the end. I think I would prefer this native naming with the bit size at the end. Thoughts? Let me see. LE60 little endian. Let's search for this one. Linux. Let me go to assembly armada time deps base config source type size. Type size. Swap type. I would also like we use the this and this. Like we use this. It was like we use the H2B and from that Reason being, it is bonkers. It is bonkers to always specify the bit width in the function call explicitly. It can lead to, it could lead to errors perhaps. The template functions are automatic. Template functions automatically choose the correct width. C style. From the past value type. Perhaps add this to the compat header instead. No, maybe not. Good. Next change. Let me get main branch. Pull rebase. Okay, and then we use we go here, code, library, source. So the debug and profile libraries, I think they're exclusive in 0, so we can probably move these over. Why are there files here? Huh? What is that? Template? Oh. Oh. Okay. Interesting. It's a template. Okay, I would say the profile and the debug, we can probably move them to core. Maybe. What about benchmark? Run benchmark. Is this ever called? Run benchmark? It is. But run benchmark. Dependencies benchmark. Okay. Then we can probably remove this guy. Yeah. So we can probably delete this guy. Yeah. And then we can take this guy. Core, library, source, templates. Templates. I mean, do we really need this template bullshit? I don't think so. I think I'll just remove it. Remove the templates. Templates. Remove templates. Westwood templates. Benchmark. Gen set age, remove www templates benchmark.h. Obsolete. Then I create a new one. Now that's interesting though. What kind of dependencies will this have? Let me see. MD profile. Set I always. Looks like that will be fine. What about this one? Same. Okay, so we should be able to move this. Okay, so we take these two and we move them to core. There we go. And then we search for Z profile. So we will look for core profile. Core profile. Core. Core E image packer. Core image packer. Core profile. Map cache builder. Core profile. Okay. Particle editor. Jeez. Patch get. Core E patch grabber. Okay. Patch get. And world builder. World builder goes here. Z profile. This goes away. Okay, good. Then we search for debug. Debug. Okay, so core debug. Core. GUI edits. Word builder. Core debug. Particle editor. Core debug. And then we need set debug, patch get. Debug for patch grabber, patch here, core debug, okay. Then here as well, core debug, there we go. And image picker, core debug, okay. And then now we should be able to remove this. Okay. Okay, then let's search for core debug. And here we need to put the core I always. And core profile, core I always. Okay, this may work. Yeah, maybe. Actually, no. There's one thing missing. Libraries. Here, profiling library. Source libraries. Here, there we go. There we go. Then let's see if that configures and generates. Yeah. Okay. Okay. Let's set it to debug though. Debug. Maybe we should also enable debug here. Hold on. Debug. and profile already have. Okay, well then actually we don't need debug here. Release will do fine. Okay, let's go. I'm very used to being explicit with the calls because of the type of work I do, but I will look at adding the helper function. Yes, of course. But the equivalent here, equivalent here. Okay, what's the new name then? Let me see. Skill points required. Yeah, I guess it's a good enough name, yeah. 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 I think you can merge this then, yeah. Well, it's still building. Why is this 100%? No particular reason other than it's slightly bigger than it used to be. Okay. I haven't been able to test. Oof. I think it would be good to test this though. It would be good to give this a brief test before commit. Okay, that has succeeded. Fantastic. Fantastic. Okay, let's double check that we have made no mistakes. So here we moved it up here. Yeah, core. Okay. Mm-hmm. 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 Yeah. 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 Mm-hmm. Mm-hmm. Let me stage all these changes. Mm-hmm. Core debug, yeah. Mm-hmm. 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 Yeah, I think this works. Then let me create a new branch. Move move debug profile libs. Mm-hmm. Mm-hmm. Okay. Then we say core move debug profile libraries to core. Mm-hmm. Move 0 hours or move debug profile, debug and profile libraries from 0 hour to core. Mm-hmm. Mm-hmm. Okay, then we push this guy. Maybe. Here. Mm-hmm. Push. All right. Mm-hmm. Mm-hmm. Push. Mm-hmm. Mm-hmm. This change removes the obsolete template.h.cpp and benchmark.h. Mm-hmm. Relates to 555. Milestone. Effector. Mm-hmm. 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 Okay. This change moves the debug and profile libraries from 0 hour to core. These libraries do not exist in generals. Did not exist in generals. Labels, unify, factor, Thompson's. There we go. Okay, then let me poke Thompson's. Next moves. Okay, so this one has built, so we can merge this, yeah. Let me double check it one more time. Progress is 0. Progress 0. Prevent possible division by 0. This minus this times 100 divided by that. So I wonder if originally the level up would be no. Fixes. Stability fixes. Yeah, that check is pretty slow here. Does this even compile on VS6? STD big file system. This should compile on VS6. This will not compile in VS6 if relevant. Could add a static assert macro. Case, if necessary. Okay, so this one I think we can merge. It looks pretty safe. Fix possible division by 0. Good. Thompson's already approved these guys. Okay, that was fast. Good. Then how about we go back to our unassemblize investigation. So basically, we looked at this in the previous session and we said that we need to implement a function that can crawl over the instructions and figure out where the end of the instructions is, the reachable end, right? The reachable end. Okay, how do we do that? Let's see. So we have instructions here at the end. All instructions are ready. So we could have a function. We could have a function trim instructions, right? Trim instructions, where we would pass instructions. Make it a private function. Private. Here. Static void trim instructions. Yeah. And then we pass this instructions. Maybe we call it trim unreachable instructions. Trim unreachable instructions. Yeah. And then, so we would also need to pass. I don't think it. Maybe we make it a member function. Yeah. So we can actually say trim unreachable instructions. Trim unreachable instructions. There we go. And then we add a new function here. Maybe we add jump destination. How about we add that before this one? Okay. Trim unreachable instructions. Okay. So, how do we implement that? There probably needs to be some recursion. Because so the conditional jumps, let me look at this guy here. Oh, is it? I don't see it. Oh, ASM instructions. What is it? This one. Here, ASM instruction, right? So there is a conditional jump, unconditional jump. So unconditional jump is easy, it's just one route. If it is a return, we are done. If it is a conditional jump, then we need to walk two paths. We need to once take the jump and then execute there. And we need to we probably what we can do is we first need to I think we need to build an array of unconditional jumps. Let me think. Unconditional jump. Vector. Conditional. Could have. We could. We have container somewhere. Where is this container? Oh boy. Util bit array bit array class bit array include util / bit array .h bit array. What does it take? Bit array. Array. It requires an allocation. No, but that's fine, I think. Okay, so conditional, but bit array, is that enough? You need 2 bit arrays, right? need 3-bit arrays. Conditional jump taken. Conditional jump not taken. Unconditional jump taken. Right? Yeah. Okay, and so I think the first we need to do is figure out how much we have. So I think we first need a pass instructions for size t, no, for ASM instructions. Oof, what's going on here with the formatting? If instruction dot Jesus, why is this hanging? Oh boy. Oh boy. Oh boy. Why? Okay. It's solved. Oh, it's so slow. What is this? Oh my gosh. So if instruction dot is jump is conditional jump. I mean, it's, let's say conditional jump count 0 to uint 32t. I can do a 16. I think that's good enough. Conditional, unconditional, conditional, yeah. Good. If is conditional jump, then conditional jump counts plus plus. Else if instruction dot is is unconditional jump plus plus unconditional jump counts. Okay. And then here we should be able to initialize this bit array. Default value is false. Not take. Okay, and now we say here conditional jump count and unconditional jump counts. Okay, so this is prepared now the the storage that we need to test if where we have a pass already taken. Next, we need to loop again, but now it will get tricky. So we go through. How do we do this? We go through each instruction, but then we reach jumps. When we reach jumps, then how do we do this? Maybe we want to avoid recursion for this. Like, there's two ways. Either we do a recursive function, or I think we can do just for loops. Yeah. Okay, so we need to advance. Then we reach a jump. We need to create some sort of checkpoint. Right. Kind of checkpoint. Okay, what we also need is uint64t furthest or largest address reached, and we initialize that with begin address, right? Largest address reached. Okay, and then here we would now do a loop here, yeah, some loop, and then at the end we would do address 64, and then we would do let me see. Should probably do it next. Should do this. So largest address reached. Actually, no. It's largest. Let's say last instruction index reached. Yeah, we go by indexes, not by addresses. Okay, so it starts at 0. And then we would do, at the very end, we would say instructions.resize, new size, last instruction reached. So we would have an assert, last instruction reached, a smaller equal instructions.size. And then we would smaller resize. No, it must be smaller than size, right? No, it's no, it should be like this. No, yeah. Yeah. And then here we can also do a shrink to fit. Okay, so we need to walk. We need to walk the instructions. Okay, we probably want to walk with index. So we say for, hold on. Let's do a size t here, size t. So we say, actually, let's do index t. Index t. Good. So index t. Resize. Okay. So for let's do a index t last instruction index, and that is that. That should be const. Okay. Then we can also put this guy here. Okay. And then we say for index t equals 0. Let's do I. I is smaller last instruction index. Plus I. Okay. Then the instruction, this should be const, by the way. Const. I. Okay. So the instruction we have by the index. Okay. Now we walk it forward, and we eventually encounter again this garbage here, right? We encounter something. We encounter that conditional jump or unconditional jump. How do we do it? I think we need a stack. Yeah. I think we need a std stack of index t checkpoints. Includes stack. So in the stack, checkpoints we can reserve. We can reserve by I think by this time, hold on. What is the max checkpoint count that we can reach? It's probably conditional jump count times 2 plus unconditional jump count. right? No. No, it's a conditional jump count plus unconditional jump count. That's a max, right? Does it have a reserve? Oh, it doesn't have one. Okay. Is this like an STD list underneath? STD stack. Probably it's like a list or a deck is underneath. Container. Deck. Okay. Okay, so we don't reserve. Well, never mind then. Checkpoints, indices. So basically, we will push checkpoints. So checkpoints, we will push checkpoints. So we reached it. Yeah. So I think when we else if instruction dot is return. Okay, let me. This won't be easy to implement. I think this will be complicated. No. Okay, so if there is a return, then we will stash pop. Does pop return anything? No. Then we do checkpoint indices top. So I equals top and then pop, right? And we will do here last instruction index reached will be std max. Std max will be I last instruction reach. Okay, and then hold on, we need to check if checkpoint indices dot if empty, then we break out of the loop. Otherwise, else we will continue. Right, so if the checkpoints are empty, it means it's a last return. Otherwise, we will go to a checkpoint. Yeah, I think this makes sense. Last instruction, index reached. Is return, index reached. If checkpoint indices empty. If it's empty, we break. Yeah, because then we're done. Otherwise, we take the checkpoint indices at top and then we pop. Good. And then if we reach a conditional jump, then what do we do? Let's first do the unconditional jump. That one is simpler. We check if the unconditional jump was already taken. If unconditional jump taken dot is set, then indexer. Why do we need an indexer? What? Indexer is set. Indexer. Huh. How's this supposed to be used? Get indexer. Okay, get indexer. I. Let's do auto indexer. Is set indexer. Then we do something. Otherwise, we do something else. Okay, so if the jump has already been taken, then is set, then we have already visited this path. Yeah. We have already visited this path. That means we can actually do the same as this one. We can do this one here. Right? If check. No, we don't break. We do conditional jump taken. Okay, it's checkpoint indices top. If a checkpoint is already set. Okay, so here, if we if we have not yet taken the jump, then we will do here dot push. No, we don't take a checkpoint. We only take checkpoints for conditionals. For unconditionals, we just follow the flow. Right. So if the jump is taken, unconditional jump. I'm not so sure right now. Let me comment this here. Okay, let's think about this first. So we need to so when we do a conditional jump, before we do a conditional jump, we need to create a checkpoint. If the conditional jump was already taken, I think indexer. If conditional jump taken, if not conditional jump taken is set, then we will do some stuff here. Else, if not conditional jump not taken is set, indexer. Actually, do we need these two conditions? I think we only need this bit array, right? Only one. Otherwise, we just by default we just follow the jump. Yeah. No, because if we always follow the jump, then we could end in an infinite loop. Yeah. No, we need to, we only need to jump once. If we meet this jump again, which can happen if we have like a loop, right? Then we need to skip it. Yeah. Yeah, so we need to skip checkpoints. This algorithm is a bit more on the complicated side. Yeah. So the conditional jump is taken. If not a set, then here we will set it. Set indexer. conditional jump not taken set. So I guess here we do the same. If not is set, let me remove all this. Let me go step by step here. Then we do conditional jump taken set. There we go. Okay. Does this make sense to begin with? So if it is a conditional jump, it will check if we have not already taken this. And then we will do something here. Let me indicate that with a ... Here we need to do more. Oh, Jesus, it's hanging again. ... Here we need to do more and here. Okay, so we haven't taken the jump yet. We do something. We have not taken the jump. No. And so we will do something here. And here we have not, hold on, this should be if not is set. Yeah. Okay, I think this makes sense to begin with. Yeah. Okay, where do we place a checkpoint now? Checkpoint. So we need to go every path once, right? By the way, there's one more problem, and that is, how do we know where to jump? We need, I think we already have such a function to get the index of where we need to jump from the bytes offset. It's probably in here, in the ImGUI app, jump lines, print ASM jump lines, get distance, this guy. Yeah. Oof. Get instruction distance. Function types. Get instruction distance. PTR diff. Get instruction distance. Address one. Distance. Address one. Instruction address two. Yeah, so I guess we need to call this guy here. PTR diff. Why is this returning PTR diff? Can we change that to UN32? Why does it have to be PTR diff? 64-bit here. I guess it's fine. Okay, so we need to jump taken, jump not taken. So if we want to take the jump, we need to get the instruction distance. So that is instructions, and then instruction dot address, and then instruction dot address plus instruction dot jump len. Right? Is that how we call it here as well? Let me see. Address 2, get distance. Target address. Yeah, it's address plus jump len. Maybe we can also target address. Okay, and the same we would do on this one here. Okay, so we have already the target address. That's good. And then here we need std optional. Std optional ptr diff t distance. Okay, and then we say if distance dot has value, then we do something. Same here. Good. Okay, so far it seems plausible. So we have not taken the jump. Now we record that we have taken it. We calculate the target distance. So we check if it is within. So this get instruction distance will only return a value if it jumps within the function. If it jumps outside, then yeah, we don't care. But if it jumps inside, then we know here. Yeah. Okay, and then how about we take a break? Has been 2 hours. Yeah, let's take a break here. Yeah, I think that would be fair. Let's take a break. Yeah. Good. I wish you a great day or night. Until next time. Goodbye.